it here.
Okay. So very briefly, 1 minute. So the system which we have built has 6 to 7 components. So when incoming transaction comes up, so it will have details like amount, time, location, device ID, account details, etc.
Right.
So
Yeah, certain type. So just for the benefit of Nitin and Radhaji. So this is basically to detect the frauds in the commercial transactions or the banking transactions. I'm not sure if it is also applicable for transactions in insurance industry, but maybe if you can just give a high level overview of what the solution does, Nitin, before you get into each of the module. Yeah.
shall I open the PPT?
I mean, you can explain verbally, it's fine, or you can do through PPT, whichever way you want to do it. I'm fine.
Okay, this
I mean,
solution.
we don't have to make it very formal, so it's okay. But just give a high level overview and background that this is what the solution does and this is how it fits into a customer's business. And then you can go about these modules of transactions, models, and all. Yeah.
Sure. So there are three solutions which we have built. One is transaction, checking the transaction whether it's a fraud, then checking the anti-money laundering, then checking the cyber, like account takeover or synthetic identity or identity fraud or some other things related with cyber fraud. So here I'm demonstrating the transaction fraud solution. The transaction fraud solution basically is applicable mainly for banking and insurance sector. It can be applied for other sector where there is possibility of fraud. So our solution is very generic. It's totally based on the data input. As long as you have the data, we can apply this solution to supply chain also. We can apply it to marketing. We can apply it to sales. We can apply it to, but we have specifically designed this solution for financial sector, for banking and insurance sector. So it can detect transaction, it can detect money laundering, it can detect cyber fraud. Cyber fraud, I think I don't need to give introduction of each of the, correct?
Yeah. Correct.
Okay. So here we are going to demonstrate the transaction fraud solution because this is the heart of the fraud. You can get away with the cyber fraud, you can get away with money laundering because there are not so strong compliance requirements from the regulation. Slowly it's coming for money laundering. It has come into UAE, it has come into India, it has come into other places for checking money laundering also. So coming to the solution now. Is this good enough of introduction or any other question?
Yeah. This is good enough. Yeah.
So the transaction comes, transaction will have its ID, it will have device ID, it will have location, it will have amount, it will have time, it will have some. So we have 6 modules which are going to check it. First is machine learning model. In addition to this machine learning model, we will have some rules which are based on the historical data generated. Or client will have some experience and he will say, okay, I have this XYZ rule and I want this rules to be used in addition to your model. So that's something in addition to this particular picture. Then after checking with the machine learning model, we check with outlier analysis, which is an anomaly detection, which basically is unsupervised learning and supervised learning both, depending upon which basically you prefer. We are looking to use isolation forest here. And then we have network analysis and fraud ring. So there's a tendency like people get together and they make a group and then they do fraud. This is called community fraud. To stop that kind of fraud, we basically have technique like network analysis and fraud ring. So network analysis is basically based on some algorithms, and those algorithms are implemented in the rule engine. Rule engine have to detect this is a part of the fraud network. Fraud rings are basically again very similar concept, but it's based on the rules, and these rules are based on the historical data. Then fourth is data profiling. So looking at the data points, you can figure out that there is something abnormal with this particular transaction. So to check that, we had data profiling, and then we had JNI system. JNI system is not very much value adding in compared to all of this, but it refreshes the model very frequently, which means like JNI system has capability to refresh the model, it has capability to refresh the model. So when you see the system performance has gone down, like you are getting too many false positive or something like that, at that point of time, it will refresh the model, and the process is automatic. In case you want to do it manually, it's possible to do it manually. And then we have case management system. So once you got all the transaction flagged as fraud and non-fraud, we do second check offline by running all these techniques on manual basis. Like we upload a Excel file with the result, and we confirm those results by case management system. And then once it's confirmed there is a fraud, then it goes to the investigation module. Is this good enough introduction?
Yeah, any question from
Yeah.
Nitin Balaji?
No, yeah, this is good enough.
Okay. So I'll stop sharing screen now, and I'll ask Eklavya to show the system. Eklavya, can you show the JNI system? Eklavya, can you hear us?
Oh, yes, sir.
Okay.
Give me 2 minutes, I'm setting it up.
Okay.
Sure. So while Eklev sets it up, what's the technology stack, Nitin? Front end, back end, what are the prerequisites?
Everything is done using AI and ML and JNI. So all the rules are generated using this technique. And those rules are implemented in a rule engine. It could be free rule engine. It could be IBM Red Hat Decision Manager, because IBM Red Hat Decision Manager allows you to model to upload the machine learning model in XML format.
Right. Okay. Now we can see the screen. Okay.
Sir, is it visible right now?
Yeah, we can see your screen, Eklev. Yes.
So basically, this is the interface. First, we have to upload the dataset and upload existing model. If we have, if we don't have,
Hey, Cleve, sorry to disturb you. Can you speak slightly louder? It's been very hard to hear you.
sure, sir, sure.
Yeah.
First, we have to upload the dataset here. For example, I upload this one. This is the insurance claim dataset. Uh, I will go to data profiler. Uh, set
Can you
some
show
basic
us what
variables.
the can you show us the content of this CSV file?
Sure. It is each row is a detail of an insurance claim, and behind that we have it is fraud or no fraud.
So this file had data of the insurance transaction, which means
Okay.
each claim, and that each claim will have all the parameter of the user who has requested the claim, and whether the police complaint has been filed, whether accident has been major, whether what kind of collision, what kind of which state, and what is the capital gain, what is the claim amount. All those parameters are there in this particular file.
So this is the data generated historical data, right?
This
So
is historical data.
historical manually collated, or
Yeah.
the pulled from some system. Okay.
This is pulled from the system.
All right. All right. So only this fraud reported yes or no. Is it a manual flag or is it automated flag?
This is a manual flag, and we need data, approximately 4,000 lines of such data, which is more like a historical data from the client to work with them. so
Okay.
that we can make machine learning model and we can validate that model so that we can check the performance of the model.
Okay. Okay.
So the prerequisite is minimum 4,000 transactions.
Yes.
So
Okay.
it is
Can you make
the
it out?
training data for the.
Yeah, that's the training data, right? Okay. So whatever they have concluded to be the fraud in the past.
So this is data profiler, which profiles the data and find basic insights to the data. For example, what is the core data type, shape, and uh, what are the mean, median, mode of numerical features, categorical features, and what is the balance of fraud feature, mean, target feature. Uh, Next, we have to set transformation rules for training our model. Here we have temporal
This
columns.
data profile helps you to analyze whether there is something unusual with the data point.
So we can actually detect whether this given data is useful to train your ML model or not. We can, the quality of data we can check, right? Is that what
Yeah.
profiler
Quality
does?
of
We check the
data,
quality of the data
Right.
quality
in
of
data
data plus
profile.
anomalies also we can check with the data point.
Okay.
Uh, then we have to set the rules. Uh, Here we can train our anomaly detection model, which is using isolation forest as the core. It will find the anomalies, which of those are anomalies and which of those are not, based on this contamination rate.
So it's to do with the outlier analysis and different techniques can be used. Here we have used random forest, but we can use isolation forest also. Now next we will demonstrate the model, how model is trained on the JNI system. It has
Uh,
built-in rule engine. So we can judge the transaction once we upload the transaction.
we can select 4 models out of these. I'm selecting 3 of them. Then we can change its, alter its parameters to train the model. So I
So
started the
here,
agent.
here he is training the model, and after training the model, he will show the demonstrator, like if you upload the new data, how it responds.
So model training has started right now. You can see. So
So
all of these models are trained.
hold on, Eklavya, hold on. So based on the training of the model, there are 3 models: Cat Boost, XGBoost, and a random forest. Cat Boost has best performance, so it's selected for using in this particular model in the fraud detection process.
We can compare all these models also. These are the main metrics. let's suppose we want to use these models, then we can go on here, fraud claim. Here we can make manual entries. Like it is saying it is 5% fraud, means it's not a fraud. And here we get the explanation which is making uh, impact on the decision.
So this is to do with the explanation of the model, what made this decision to this. Show the file version also.
I'm putting this here. Hold on, I think. So this is a test file I have uploaded, which have these examples, 10 examples. I have
So
no
this is a
fraud
new data.
recalling.
On this new data, we will do the prediction using the model.
So here is a new prediction, and it also predicted anomalies. Like this is not fraud, this is fraud, this is not fraud, this is
And this
fraud.
is
And we can get
explanation.
explanation of all the cases.
So this was the main thing, main application which basically detect the fraud using the model. And now we will move to the network analysis module, which Aditya will show.
So should I stop sharing my screen?
Are you done?
Yeah.
Okay. Aditya, can you show the network analysis module?
So, Nitin, who are the target audience for this particular application you showed me so far?
Target application audience is
Target
like
audience.
everybody who is doing a transaction.
But setting up all these parameters, it seems all very technical, right? But somebody with the statistical knowledge only can actually set up those rules, right?
It has to be done by technical team, their team, and we will train their team who basically
Okay.
will to set it up. Once it set it up, it will start working without any break.
So when you say technical team, what kind of skill set we are looking at? What kind of
We are
people?
looking at Python, we are looking at machine learning, we are looking at JNI, that kind of skill.
Skill set you need?
Yeah, Nitin. So that is something that even your team will be able to do the one-time setup, right?
Yes,
Yeah. And once the one-time setup is done, that's when the users can go to the business user screen, upload their data, and do the analysis.
it will be not like manual thing. It will be more like when transaction come, it will go to the application. It will go to the application. Application will have that particular GUI built in, and that built-in GUI will basically uh, will get the transaction, get call the rule engine. Rule engine will decide the reply with the yes or no whether this is a transaction fraud or not. So we don't need to do manually anything. In case we want to do manually, then we can do manually also. We will provide that option also.
So
But
for
you
the
know, the
application, you mean there will be API calls, you have API endpoints to integrate with existing banking or insurance transactions systems?
Yes.
Yeah, rather you were saying something.
yeah, so see, most of the data points and graphs stuff which they're showing, it all seems to be very technical, right? So the normal guy may not be able to understand what it means, what those numbers mean, what the plus minus means. So, and again, fraud is very dynamic. It changes every day. People are coming up with new ways of defrauding the system. So, how do we keep those, keep the system updated? We can't just set it for one time and forget about it. So, we may have to tweak it on daily basis, maybe hourly basis. So, how do we provide for that kind of
Uh, thing is,
dynamism?
thing is to take care of that particular situation which you mentioned. We have come with the JNI system concept, which
Okay.
means if model performance goes down, you notice that at the end of day, at the end of week, end of month, then you need to just refresh the model with the latest data, and it will rebuild it, it will test it, and it will deploy it without any break.
But so it is more like a reactive system, right? Not proactive. Where so we are, to this month I detect a very less fraud, so I think the model is not performing. So I retrain with the latest data. That's how it works. So it's not really a reactive system where it automatically detects there is something. The system is not
Uh,
optimal. No,
I would, yeah.
I'm just
So,
getting clarity of the system works.
okay,
So
let,
either way,
let
it's
me
fine. Mm,
let me go into architecture again because
mm,
that will explain everything.
right.
So we have we had this particular demonstration to you this module and 1 minute this module and this module, but
Okay.
there is something called network analysis, which
Mm,
means if somebody has done fraud and he comes
mm,
up with somebody else and do the fraud, it will basically proactively check on that person whether he's a part of the fraud network. That is one
right.
thing.
Okay.
Second thing, uh, anomaly detection, which means that also will check on each transaction data point, and it's unsupervised learning also, which means you don't need basically to tell the system this was a fraud, this was not a fraud. It can work without that also. So
Okay.
that is second thing. Third one is data profiling. With the data profiling, we will generate some rule which will check each data point proactively that whether this is a fraud or not a fraud.
Right. Okay. So this has geolocation, devices, transaction frequency. So okay.
It will have,
So unusual behaviors. It's data profiling. Right.
yeah,
Checks
yeah,
for unusual profile. Okay.
yeah, yeah.
Transaction analyze in context of network graphs to detect links. Okay. All right. So these two are proactive, right? So because they're detecting real time. So
These
where
three,
which
these three,
network the
these
system
three.
is going in.
Artwork analysis, network analysis, and data profiling. These three are looking to do the things on a proactive basis, and this
Okay.
will do the things based on the reactive basis. And we are most advanced. We have compared our solution with FICO, says none of them has GNI system in their system.
Okay. Right. So we have one static system which is model, so may not actually static, but can be refreshed. And the outlier network and the data profiling are proactive systems, so real-time detection. And
Yes.
on top of it, you have Gen AI system, which so what it does, the generative ML level is context and
GNI system means like GNI, it see the response of the user. Based on that, it basically decide whether model should be refreshed or model should not be refreshed.
okay.
Yeah. And
So,
in case you report it on daily basis, it will refresh on daily basis. In case you
mm,
report it on weekly basis, it will refresh on the weekly basis. So this is very quick one.
Okay.
Yeah. Any other
Yeah.
question?
No, yeah, go ahead. I may ask more if I need some clarity. Yeah, go ahead
So,
with this.
yeah, Aditya, can you show the network analysis and fraud ring?
Yeah, just let me share it. Yeah, so it's visible.
Not, yes, no, it's coming.
Yeah. So now is it visible?
Yes, visible.
Yeah. So yeah, let me show what does network analysis do here. Yeah, so let's upload a data set. Suppose we have using a pre-processed data and we want to see the accuracy by which we can use different machine learning algorithms to form fraud rings. Means those nodes which are depicted as fraud in the total column. Yeah, so let me show you how it works. Yeah, so we have two options here. Two variable network, that is, two variable will contribute to the fraud, and then we have multivariable network. That means we can select multiple features and a target feature here. Yeah, so let me do a two variable fraud. Yeah, so let me select the first variable as loan amount, second as interest rate, and here our target is fraud. So yeah, here I'm using a random forest algorithm and I will be training it for 300 epochs. And I'm displaying 50 nodes because if we display more than that, it becomes cluttered, but all the nodes are processed in the backend, so we can get the data for all the nodes. Yeah. Yeah, so here we have two algorithms which I'm using. One is Leuven, another is Leiden algorithm. These are the benchmark for the network analysis in current industry standard. And see, here we have the accuracy for our random forest, and this is the node centrality measures for all the nodes which are in the fraud ring here. So here we have all the nodes which are currently in the 50 network. Yeah, and the red nodes, which are the red nodes here marked by the legend, are the nodes which are in the fraud network. So we can visualize how the connection between the fraud networks here. And I've also provided lead-in community detection to as here also we can just see the fraud nodes are here, which are depicted in red. Yeah, and then we have the edge details, which we can see where how the source target and which label is there. If it is label 0 means it is not fraud. If it is label 1, as we can see here, means this network has a fraud in it. Yeah. So should I move to multivariable?
Yeah.
Yeah, so here in multivariable, we can select any number of features. Here previously it was just two. Let me select three here: loan amount, interest rate, and installments. Yeah, and let's make the graph a little smaller because otherwise it will be very hard to see. Yeah, let me change the algorithm here to something like a decision tree and run it. Yeah, so here also we have Leuven and here Leuven and Leiden, and here we have more features contributing towards the fraud rate. Previously it was just two, and then we have target. Here we have more three features and a target. So here red one are the fraud nodes in this network of just 20, which I'm displaying currently, and this is through Leiden. And again, once again, we have the edge label details, means this network.
Go up. Just show the first graph. Show the first
Yeah,
graph.
yeah, this is
So,
the
so idea behind is like if you want to have a look at the association with the fraud, then it will tell where the fraud is associated with which variable and how it's associated. So with each variable, you can see whether this is leading to the fraud or not. Make sense?
So if this there is something called 16,000, what does it mean actually?
This is a
In the top.
variable value,
Okay.
and it says that this particular variable is associated with the fraud because it's in the red color.
Correct.
So, like if let's say take the case of the medical claim. In the case of medical claim, it could be doctor and the patient. They basically get together and they do insurance fraud.
Right.
So we can select those two variables and check whether they are contributing to the fraud somewhere. So using each variable, you can analyze whether they are contributing to the fraud. If you notice there is something abnormal with any variable data, any particular doctor, then it will be possible to note that particular thing with this particular graph. So it proactively will tell you where's going to go, where next fraud is going to happen, and how it's going to happen.
Okay.
Yeah. So this is one. Next we'll show the. Do you want to see the? What is next thing, Aditya? You have?
Next, yeah, just let me check. I have fraud rings as well and data pre-processing
No,
and
no,
early
no.
warning system.
So we have made early warning system also. That early warning system basically monitor the different variable. Once they cross the threshold, then it will basically tell you that this threshold has crossed. And can you show the Aditya that as well?
Yeah, just give me 2 minutes and I will just share it.
So this early warning system is like a pre-requirement by RBI in India, and you should have early warning system plus fraud detection system. So we'll show you early warning system very briefly, and then we'll show the transaction monitoring and analysis.
Is it visible?
Yes, yes.
Yeah, so I have the early warning system here. There are two options currently for the early warning system. One is the upload data, which will be through a pipeline, and data will directly come here. Or if there's some special case that we want to check, we can also have a manual entry here that we can put manual values. Yeah, so let me show both of them. So currently, there are rules here for the early warning system. Let me just show for two of them. Yeah, so yeah, we can upload for the high value check bouncing data, which is a CSV file, which we can get from the client itself, and we can just fine tune it and we can see how what are the required columns at least.
So idea here is like data will come to this system, and this system will basically throw exception when you cross the threshold.
Yeah, so I've uploaded two data set here, for one for high value check bouncing and the for payment delays. And these are the at least required columns which we require for it to check whether they are violating the rule or not. So we can just set the threshold, we can change it as per we want. Yeah, let me check the account status here and we can see which accounts are being flagged here. We can see account ACCT 10276 has been flagged because it is having a problem high value check bouncing, and we have here we can see 10263 has the problem of payment delays detected. So these are all the accounts, or we can just go to monitoring dashboard here and just get a proper view of this. Yes, so in Monty dashboard, we have a summary of it and which rule and which warning they have violated. And we can also see the warning rule types, means 23 violations of this rule. And then we have 9 violations of payment delays. And we also have severity analysis. Currently, I'm just adding two of them. But if the multiple rules were selected at once, so we will have different severity analysis, high risk, medium risk, low risk. Currently, everything has just a one rule violation, so it's just showing low risk. Yeah, so let me move. Can I move on to manual entry?
No, it's not required. Let's move to Anurag.
That's
Anurag,
Yes, sir.
can you show the transaction monitoring system?
Yes, sir. Just give me a minute. Is it visible, sir?
Yes.
So this is the transaction monitoring dashboard. So these are the navigations. First, we will upload the data set, and this is the data agnostic code. So here we can see the data set preview. And if we want to see like first 10 rows, first 20 rows, or last 20 rows, we can manipulate from here. And here we can see the shape and size of the data set. And if we choose like transaction amount here, it will show the total transaction amount average and the total transactions. And these are the recent transactions which we can see here. So if we want to see first 5 transactions, this is by default first 5 transactions. And if we want to see it first 10 or first 15, it will show from here. And if we want to see the transactions by date, we can choose by any date. Let's say 2023, and let's say 2020, it will reflect here. And these are the transactions insights. If we want to see the numerical column like transaction amount, it will show the histogram of this transaction amount distribution. And here it is showing the transaction amount analysis by status. Like these are the transactions count per category. These are the category. These are the values of category like completed, failed, pending, and these are distribution. Like completed transactions are this one, failed, pending, and reverse. And this is its pie chart, which we can see. And here we are seeing the highest and lowest transactions. And if we want to see the transaction frequency, here are only the categorical column we can choose. Let's say access method.
Anurag,
Yes, sir.
so this particular thing application basically helps to generate the report for the management, and those reports basically are based on the request of the customer, what he want to see in the report, whether he want to see the amount, whether he want to see the frequency, whether he want to see the time, whether he want to see what went wrong, how many went wrong. So all those information is provided through this particular tool to the customer. Go ahead.
Yes, sir. So here also we are seeing the highest and lowest uh, regarding to the access method. So these are the values of access method, web browser and mobile app. And this is the filter data set by categorical. Let's say we can choose transaction status, and the in transaction status there are 4 values like completed, reversed, failed, pending. Let's say pending. We can see the pending data set only. This one. And this is just the distribution, geographic distribution of transactions. Where are the transactions are in which city or country. Then the second one is fraud alert. Here we can adjust the threshold of fraud alert. By default, it is 6. If we set to like 30, it will show the fraudulent transactions 43% and its total amount. And this will highlight the risk score of fraudulent transactions. And if we want to download the fraud alerts, means uh, these data sets, we can download also. And here it is also reflecting this line chart. Like if we let 20, it will reflect this one line chart also. And here we are seeing the top fraudulent transactions. And this is the investigation panel, like by name, means if we want to see top 10, it will show the customer name with how many fraudulent transactions they did and their customer ID. And these are the customer risk profile for a particular customer. Like if we want to see Arav Patel, There are numerous names, but their IDs are different. Means these are the different name with same name but different user ID, and they're fraudulent transactions also. And this is the distribution of this dataset. And the third one is the report and analytics. Let's say transaction status. It will show the fraudulent visualization by transaction status. Means in completed transaction status, the fraud counts are 25, failed 19, reverse 18, and pending 17. And this is the bar plot of this fraudulent visualization by transaction status. And if we want to see the full fraud data for transaction status, we can see this. These are the transaction status which is highlighting. And if we want to see the what we can say transaction or transaction data by daily, weekly, or monthly, we can uh, we can check the radio button from here. Like this is the by default a daily transaction timestamp, but if we want to see the weekly transaction timestamp, it will reflect from here, and this will also change this line chart. Like if we want to see the monthly, it will reflect this. Means if we it will sort this, and it will also sort this. And if we want to see the fraudulent and legitimate transactions in percentage, it will show from here. Like the total fraudulent customers are 79 and total legitimate customers are 4,921. And the next one is our user behavioral analysis functionality. This is the failed login attempt. Means how many login attempt get failed. This will show their customer ID, and this will show their failed attempts. And this is the distribution failed login attempts. Like how many failed login attempts are and how many counts are. Like these are the count of failed attempt 1, which is 982. And these are the high value transactions, top 5% we can see from here. And this it's a graph which is a bubble plot. This is the highest one, and we can see its customer ID, its type, its timestamp, and amount, the highest amount. And this is the unusual access time. Means the customers who did transactions after 10 p.m. We can see here they and their customer ID, timestamp, transaction amount, and transaction type. Means from where they did transactions, like from UPI or credit card or stock trading, like that. And this is the unusual transaction by customer ID, amount, and type. A bubble plot means this one. And this is the most common transactions types and its average amount. And this is its bar plot, and same for pie chart. And is
I think this is enough to demonstrate. Hemant, Nitin, any question? Hello?
Not from my end.
Ravi?
So these are the top player in the market: SAS, NICE, ACI, Experian, and then we have compared ourselves against all of them. And we have compared on this architecture, like what kind of feature they have, and some of them have their proprietary algorithm, which definitely we cannot violate. But our best hope is like marketing our base ourselves on the cost, marketing ourselves on the based on the JNI system, marketing ourselves based on the proactive system, because most of them are not that proactive as we are. That is one thing. And then we have compared ourselves based to the USP, like accuracy, rule update time, scalable, customization, innovation, reporting, user friendliness. I'll share this presentation with Hemant,
Sure.
so he can have a look. And then we have compared ourselves with the FICO, and I'm happy to say that we are in par with FICO, if not better. But we are cheaper also,
Mm.
and we are fully customizable.
Right.
And then we have compared ourselves against SaaS. And with the SaaS, again, we are sitting on the all feature. I think we are getting better than SaaS, not better than FICO. FICO,
Yeah.
we are far in.
I mean, pricing, of course, can be a big changer, but yeah, they have been a brand. We have to just sort of get started. Okay.
Other thing is, I would mention like we are going in a bundle. Like other customer, they basically are providing transaction fraud solution separately, and then AML solution separately, and cyber fraud solution separately. But what we are doing is we are offering a bundle, and with the bundle we will offer very heavy discount, and then I think we have good chance to go as a bundle.
Right. Let me ask you one question. Because as I said, whatever you spoke was a French for me. So I'm just throwing some question, whatever comes to my mind. Do you think integrating such solution with either a card management solution or with a payment gateway makes sense, or does it only gets integrated, or does it only make sense to integrate with maybe a core banking or a digital banking kind of platform?
It can be integrated where you have fraud. We have providing API.
No. Not from a technical point of view. I'm asking from a functional point of view. Does it make sense to integrate with a payment gateway and a card management solution? Or does it
Yes,
only make sense
yes.
to integrate with a core banking or a loan origination solution, which is more of a backend system? Because card management and payment gateway are customer facing, right? The LOS, the loan
So
origination system, and the core banking are backend systems. So, I mean, this is a functional question, not a technical question.
yeah, answer to that is you need to integrate with the front end system, because you need to do the transaction fraud detection on the front end, and then you need to make decision within less than 10 seconds whether this is a fraud or not a fraud. So it has to be integrated on the front end.
Why I'm asking you is because currently we work very closely with a couple of payment gateway solutions provider, and we
Mhm.
also work very closely with some card management solution providers. So if it makes sense to work with them, then I think it can be a good bundle even for them as well.
It is a good bundle, because this is using the most latest technology and
Mm.
providing the technology beyond expectation. That's what I would say, because nobody has thought that they can refresh the model in 24 hours, but we can. Nobody has thought that they can refresh they can be proactive, but we are proactive.
Right.
Normally, they have certain rules in the past, and those rules basically used to detect the fraud, and those rules used to get updated either 3-month basis or 6-month basis or 12-month basis, depending on how much customer is willing to pay.
Right. Okay.